Welcome to ClickMyProject.com. Now we are going to discuss about the project efficient seizure prediction and EEG selection based on multi-objective optimization. Now we are going to discuss about the abstract of the process. Among the lot of medical signals, EEG is one of the most commonly used signals in the medical field to detect the epileptic seizures. The epileptic seizures detection using the deep learning is presented in this project. Here the deep learning is convolutional neural network is used to extract the features from the signals. The seizure prediction and analysis by the EEG signals is to prevent the unwanted life risk from the diseases. The main motivation of this process is to implement a method that will apply to EEG signals of the whether it is based on the normal or abnormal. We have to classify these things. The deep learning based convolutional neural network algorithm is used to extract the feature from the signal. Then the extracted feature from the signal is generated as a test feature. Then the test feature vector will be generated. After doing this one, then the classification is done to classify the abnormality of the signal. The seizure classification is done by means of the machine learning classifier. Hence, the machine learning classifier is used to detect whether the signal is normal or abnormal. The classification performance will be evaluated to identify the efficiency of the process as well as the efficiency of the classification rate by means of the accuracy and error rate. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists the modules such as input signal, pre-processing, data splitting, feature extraction, classification, that is nothing but the feature matching, then the performance estimation. These are the 6 modules present in this project. First of all, the input signal is taken from the dataset. The dataset consists of lot of EEG signals which consist of both the normal as well as the abnormal signal. The user can select any one signal from the dataset. After doing the selection of the input signal from the dataset, the pre-processing will be carried out. In this pre-processing, we have done the major thing is noise filtering. Hence, the signal consists of any noisy peaks present in the signal. It will be removed by using the noisy filtering. So after doing the filtering method, we just shortlist the length of the signal. In case the input length is too much of long, in the sense it will take too much of time to the execution, so we have to shortlist the length of the signal. After doing the pre-processing, the data splitting will be carried out. In this data splitting, we have two kinds of data is there. One is the test data, then the another one is the train data. So we have to split the data into one test and a train category. For example, we have thousands of signals in the dataset. In the sense 800 will be split into one train and 200 will be split as a test. That means the 80% of data will be the train data, 20% of data will be the test data. After doing the data splitting, we just move to the feature extraction. So in this feature extraction, the test feature will be generated from the input signal. So first of all, the feature will be extracted by means of the convolutional neural network, that is a kind of the deep learning algorithm. We have to extract the signal by using this algorithm, then generate the test feature from the input signal alone. After doing the feature extraction, already we have train data also, so we have to import two things for the feature matching. So in this feature matching, train feature and then the label will be included, so along with the test feature. So these three things will be the input for the classification. Then the classification is done to estimate whether the input signal is normal or abnormal by means of the machine learning classification named as support vector machine. By using this classification, the final result of the process will be displayed as normal or abnormal. So after that, the final stage of the project consists of performance estimation. So in this performance estimation, we have an accuracy, sensitivity, specificity will be evaluated to estimate the performance of the classifier. Now we are going to discuss about the running procedure of the process. At first, open the Spider 3.7 and then change the current directory. If you want to execute the file, just open the mainfile.py and click this run button. After doing this clicking run button, we have to open the dataset. After opening the dataset, you can see the several signals in this dataset. So we have to select any one signal from the dataset. After doing the selection of the signal from the dataset, the process will be done automatically one by one. Now the process results will be shown in the console one by one. We can see the results here. Now this is the input signal which we have taken from the dataset. The user taken dataset is here. After doing the selection of the input signal, the pre-processing will be carried out. In this pre-processing, already we have discussed about the filtering. So the filtering is applied to remove the noises from the signal. So here the noisy pixels will be removed by using the filtering method, by using the Butterworth filter. After applying the filtering, we have to extract the features from the signals. So here the values represents the feature values from the signal. After doing the extraction of the features from the signal, those values will be saved as an test feature. Then the train feature will be carried out to extract the features from the each and every signals present in the dataset. So here this is the steps to extract the features from the every datas. After doing this one, we have to split the data into one test and train separately. So the size of the test features will be the 20%, then the size of the train features will be the 80%. After doing this one, we have to apply the convolutional neural network to extract the specific features from the signals. So this is the step to extract the convolutional neural network. So after doing extraction the convolutional neural network, we have to classify by means of the machine learning classifier. So here the support vector machine is used as an classification. The classification result will shows whether the signal is normal or abnormal. Here we have selected one signal which is relevant to the abnormal, so the result is displayed as an abnormal. Then finally the performance of the overall process will be evaluated by means of the accuracy and error rate. So the accuracy is around 99.3%, error rate is around 0.6%.